Vector integration. Morning, I'm Kavitha, Assistant Professor in Mathematics, H&S Department. Vector integration. Closed curve. Before going to vector integration, we discuss about closed curve. Let C be a curve, let A be the initial point and B be the terminal point of the curve. So what is here? Observe one curve is there, that is a curve here. One curve is there. What is that curve? A is the initial point, B is the terminal point of the curve. The direction along C oriented from A to B is positive. Then the direction from A to B is positive and B to A is negative. Observe here, A to B is positive and B to A is negative. If the 2 points A and B coincide, the curve C is called the closed curve. Here observe one more curve is there. What is that curve? Here A and B are two, or what is that here? Initial and terminal points both are A and B are touching each other. So this is called closed curve. So what is closed curve? See, closed curve is if initial and terminal points are same, then that is called closed curve. Then one more it is there. What is that? Smooth curve. Smooth curve. Smooth curve is what? A curve R bar, F bar of T is called a smooth curve. If F bar of T is continuously differentiable, a curve C is said to be piecewise smooth if this is the union of finite number of smooth curves. What is the meaning of this means? Smooth curve. Smooth curve. A curve R bar equal to F bar of T is called smooth curve. Curve F bar is continuously differentiable. It is continuously. A curve C is piecewise smooth if is the union of finite number of smooth curves. Union of finite number of smooth curves. So this is called smooth curve. Okay. Then we'll go to line integral. In integration, vector integration, what is it? First we'll discuss about line integral. After the surface integral and volume integral. Before, what is line integral? Observe here. Line integral is line integral. Let r bar equal to f bar of t. Define a smooth curve C joining points A and B. Let ds be the differential arc length at P. You know that curve is what? Integral of A to B. Integral of A to B is there. Let ds be the differentiable arc length at P belongs to C. Then dr bar by ds t equal to t bar. Dr bar by ds equal to t bar is the unit vector along the tangent to the curve C at P. Along the tangent to the curve at C at P. Let f bar of bar be a vector point function defined and continuous along C. F bar or be a vector point function. What is f bar? F bar be a vector point function defined and continuous along C. So then next, what is that? The component f bar of bar belong along the tangent at P is f bar dot t bar. The integral of f bar dot t d bar ds taken along the curve C is called the line integral. Called the line integral. What is the line integral definition? Is what it is? The integration of A to B f bar dot t bar ds. Then integral. You know that what is the t bar? T bar is nothing but r bar by ds. So then you'll get f bar dot d bar. This is the line integral formula. What is the line integral formula? Is integral of f bar dot d bar. Integral of f bar dot d bar. Then we'll discuss about the circulation. What is the circulation? If it is a closed, then we'll discuss that a closed interval circulation. If r bar represents the velocity of a fluid particle and c is the closed curve, then the integral of v bar dot d bar is the circulation of r bar around the c. So what is that? V bar is called v bar dot d bar is called the circulation of r bar. If v bar d bar equal, then field v bar is called a conservative, that is no work done and the energy is conserved. So v bar dot d bar is called circulation of v bar, then around the c. Circulation means you know that it is a closed curve. Closed curve terminal and initial points are both are same, then that is called circulation around the c. Then equal to both initial and terminal points are both equal, then it is, then you'll after integration you'll get anywhere that is 0. So then field f bar equal to v bar is called conservative. If you'll get the 0 of this integration, that field is called conservative, means there is no work done in that particular energy. So that is called work done. Okay. Next we'll discuss about work done by a force. If F bar be a F bar B represents the force acting on a particle moving along an arc AB, then the work done during a small displacement del R is F bar dot del R. Hence, the total work done by F bar during displacement from A to B is given by line integral. Then what is work done means, if some particle, the force acting on a particle moving along an arc, then the work done during a small displacement del R, then f bar dot dr is, hence the total work done by f bar during the displacement from a to b is given by line integral of integration of a to b f bar dot dr. This is the formula for work done by a force. So then next we'll go discussion about some problems we'll do on line integral, based on line integral. One problem is there. What is that problem? Evaluate integral of f bar dot dr, where f bar equal to x square I y square j and c is the curve y equal to x square in the xy plane from 0 to 0, 0 comma 0 to 1 comma 2. What is given f bar? You need to find the line integral of f bar dot dr. F bar dot dr. So x square, here it is given, function is given, f bar is given, vector point function is given, and c is the curve. What is the curve here given? Here is y equal to x square in the xy plane from 0 comma 0 to 1 comma 1. First of all, you know that r bar position vector r bar equal to xi plus yj, dr bar equal to dxi plus dyj, dr bar equal to dxi plus dyj. Integral of, you know the formula of line integral formula, that is integral of f bar dot dr equal to, already f bar is what it is given in question only, f bar x square I plus y square j dr bar dxi plus dyj. Then dot product, in between dot product is there, dot product is there means I dot I is 1. So x square dx plus y square dy you will get, after dot product you will get x square dx plus y square dy. Before going to that, what you have to do there, here it is given condition, what is that curve is there, along the which curve, y equal to x square in xy plane, y equal to x square in xy plane. So y equal to x square in xy plane. So we take y equal to x square, dy equal to 2x dx, y equal to x square. If you want, you can take x equal to root y also, it is also correct, then you'll get the same answer for that, dy equal to 2x dx. So it is given in question, what happened here, 0 comma 0 to, along the curve y equal to x square xy plane, it is 0 comma 0 to 1 comma 1. So x varies from, here what are the coordinates of x? X 0 comma 0 to 1 comma 1. That's why x coordinate is 0 to 1. X varies from 0 to 1. Then in place of y equal to x square. Y equal to x square equal to x square, dy equal to 2x dx, 0 comma 0 to 1 comma 1. X varies from 0 to comma 1. X square dx, y equal to x square. Then put y equal to x square, wherever you will get y, then you will substitute in place of y x square. So x square dx, x square whole square 2x dx. Integral of 0 to 1, x square dx plus 2x to the power of 5 dx, 2x to the power of 5 dx. So after integration, what is the integration of x square? X cube by 3 plus 2 into x to the power of 6 by 6, 0 to 1 apply, then you'll get the answer 2 by 3. So if you'll do with respect to what y, if you'll take, you want to take in place of x root y, then you'll get the same answer for that. X equal to root y, you will get the same answer for that. Okay, this is the how to find the line integral using along the curve y equal to x square. If f bar equal to, next one more problem is there, that is what, if f bar equal to 3x square y 3xyi minus y square j, evaluate integral of f bar dot dr, where y equal to 2x square in the xy plane 0 comma 0 to 1 comma 1. So same previous problem, but here curve is different and f bar, it is curve is given y equal to 2x square, f bar is 3xyi y square j, r bar equal to xi plus yz, dr bar equal to dxi plus dyj. You know that position vector anyway, r bar equal to xi, if you are doing with respect to r bar, then you will get the dxi plus dyj. So f bar dot dr, 3xyi minus y square z dot product 3xi plus dyj. So 3xy dx minus y square dy, wherever you will get, after difference in dot product, in between dot product is there, what you have to do there, 3xy dx minus, you will get y square dy. So y square dy, what you have to do there, actually here y equal to 2x square is there, y equal to 2x square, y equal to 2x square means you, in place of y, what you have to substitute here, 2x square is substitute, then 2x square, y equal to 2x square, dy equal to what you will get, 4x dx, then 4x dx. Your y varies from 0 comma 0 to, so your y varies from, x varies from 0 to 1, x varies from 0 to, wherever you will get y, in place of y you need to substitute x square, 2x square in, and in place of dy, 4x dx, then in between the limits 0 to 1, 6x cube 16x to the power of 5 dx, 6x power 4 by 4 minus 6x 16x to the power of 6 by 0 to 1 minus 7 by 6 is the answer for that. Here one more problem is there, but what is the problem in terms of x, y, z, or in terms of t? So what you have, find the work done by the force F bar equal to 3x square minus 6yzi plus 2y plus 3xj plus minus 1 4x minus 1 minus 4xyz square into k in a moving particle from the point 0 comma 0 to 1 comma 1 comma 1. Here x and y and z is given, but what is it is here, it is a line integral, means you need to integrate with respect to any either x, y or z, not by 3. So, but here what is the given here, x equal to t, y equal to t square and z equal to t cube. X equal to y and z equal to, y equal to t square and z equal to t cube. So first what you have to do here, work done, you know that the formula of integral of f bar dot dr, it is given. What is f bar? F bar is integral of, f bar is 3x square minus 6yz into I plus 2y plus 3xzj plus 1 minus 4xyz square k. Anyway, what is position vector, r bar equal to xi plus yz, dr bar is what, dxi plus dyj dzk. So f bar dot d bar, f bar dot d bar, in between dot product is z. For the dot product, anyway I dot I is 1, j dot j is 1, k dot k is 1. Using that, first we will get 3x square 3x square minus 6yz dx plus 2y plus 3xz dy. 1 minus 4xyz square dz. Endpoints are given here 0 comma 0 0 comma 0 to 1 comma 1 comma 1. Here what is x equal to, y equal to, z equal to given. What is x? X equal to t. So then dx is, if integrate with respect to x on, then what you'll get, dx by dt. Then you are integrating with respect to t, that's why you are getting t as 1. Then dx by dt equal to 1, then you'll get dx equal to dt. Then y equal to t square. So dy equal to 2t dt. So dy equal to 2t dt. Z equal to t cube. Dz equal to 3t square dt. Dz equal to 3t square dt. First one is what? Z equal to t cube. X equal to t, y equal to t square, z equal to t cube. Dx equal to dt, 2y equal to 2t dt, dz equal to 3t square dt. You need to find the values. To find the values of t means the limits, you need to find the limits for t. How will you find the limits for t? Observe here, it is given coordinates of x, y, z, 0, comma 0, comma 2, 1, comma 1, comma 1. What is x equal to t? If we substitute in place of x equal to 0, then t will become 0. So in place of x equal to 1, t becomes 1. So here you are getting x, t, y. If you substitute x equal to 0 and 1, then you are getting t equal to 0 to 1. Again, we'll move from y equal to t square. Y equal to t square. If you substitute y equal to 0, then what will happen here? T equal to 0 you'll get. Again y equal to 1, then again you'll get t equal to 1. Y equal to 0, you'll get t is 0. Y equal to 1, t equal to 1. Why? Because 1 square is, you'll get 1 only. So then we'll move from z equal to t cube. Z equal to t cube, z equal to 0, t equal to 0, z equal to 1, t equal to 1. What is the meaning of this? If you substitute in this z equal to 0, you'll get t equal to 0. Z equal to 1, t equal to 1. That is the meaning of. Then each and every in x, y, z, your t varies from 0 to 1. T varies from 0 to 1. T varies from 0 to 1. That is the meaning of the t varies from 0 to 1. Your t varies from 0 to 1. Then what is that line integral? Line integral means it is a single integration symbol you will get. Now you are all x, y, z in terms of t, and t limits are 0 to 1. Now we'll find the line integral for that. So work done. It is f bar dot dr. Integral of 0 to 1. 3t square minus c 6t to the power of 5 dt plus 2t square plus 3t to the power of 2 tt minus 4 in place of, wherever you will get in place of x, t, y equal to t square, z equal to t cube. Then dx equal to dt, dy equal to 2t dt, z equal to 3t square dt. Substitute all this in your all terms in terms of t you will get. So 12t to the power of 11, 4t cube plus 6t square. What are the limits? T limits are anyway 0 to 1. You know, t varies from 0 to 1. So after integration, you'll get t to the power of t power 11, t to the power of 12 by 12, 4 into t to the power of 4 by 4, 2t cube by 3. Apply the limits, then you'll get 2 is the answer for. What is that problem here? X, Y, Z in terms of t is given. You need to find the limits for that and find the each and every to dx, dy, dt, then apply the limits, then you'll get the answer. Means for this is answer is what? 2. Next problem. Find the circulation. Circulation is nothing but, what is the problem? Find the circulation. F bar equal to 2x minus y plus 2z into I plus x plus y minus z into j plus 3x minus 2y minus 5z into k bar along the circle x square plus y square equal to 4 in the xy plane. In the xy plane, circulation means you need to change into all into polar coordinates. First, we find the f bar and d bar, f bar dot d bar. What is f bar? 2x minus y plus 2zi plus x minus y minus z into j, 3x minus 2y minus 5z into k. R bar equal to xi plus yz plus zk, dr bar equal to dxi plus dyz plus dzk. F bar dot dr. F bar dot dr is what? 2x minus y plus 2zi. In between dot product is there. What is the dot product? You know that. What is the dot product? That product is I dot I is 1. Then j dot j is 1, k dot k is 1. So after that dot product, then you'll get this 2x minus y plus 2z dx, x minus y minus z dy, 3x minus 2y minus 5z into z dz. But it is given in xy plane. If it is in xy plane, then z-axis equal to 0. What is given in question only? It is given what is that in xy plane? It is given z equal to 0. Wherever you will get z, then in place of dz and z, you need to substitute 0. In xy plane, what is the meaning of xy plane? Z equal to 0 and dz equal to 0. So wherever you will get in this, d in place of z, substitute z equal to 0 and dz also 0. Now we will find the circulation. For that circulation, f bar dot d bar, where c is the circle. Now we will find that where c is the circle. What is the circle? It is given in question x square plus y square equal to c in the xy plane. That's why in the xy plane, that's why you're getting where c is the circle. So circle equation is what? X square plus y square equal to 4. So what is the radius? X square plus y square equal to 4 means what is the radius of this? Radius is 2. Now we'll write the polar coordinate. Polar coordinate x equal to r cos theta, y equal to r sin theta. X equal to r cos theta, then integrate, differentiate with respect to x theta, then what you will get? Dx equal to minus 2 sin theta d theta. What is the value of dx? Minus 2 sin theta d theta. X equal to r cos theta means in place of r you need to substitute 2. In place of so after differentiation, you will get minus 2 sin theta d theta. Then y equal to r cos theta. That is y equal to 2 sin theta. Why? Because here r is 2, no? That's why. dy equal to 2 cos theta d theta. Then it is a circle. In circle, what is the angle? 360 degrees means 0 to 2 pi. Circle theta varies from 0 to 2 pi. So now we'll apply in place of anyway after dot product, in place of z 0 and in place of dz 0. Then you'll get the x2x minus y dx plus y dy. Wherever you will get in place of x, you need to write 2 r cos theta means 2 cos theta minus 2 sin theta d theta. 2 sin theta in place of y, 2 sin theta in place of dy, 2 cos theta d theta. Substitute the integration limits are limits are 0 to 2 pi. 2 cos theta minus 2 sin theta. 2 sin theta, apply all the values of that in place of that. At last, what you will get? Minus 8 cos theta sin theta plus 4 sin square theta plus 4 cos square theta, 4 sin theta cos theta d theta. So then minus 4 cos theta sin theta plus 4 sin square theta cos square theta d theta. 4 minus 4 cos theta sin theta d theta, 0 to 2 pi, 4 d theta. Then here apply limits 4 cos theta, 4 sin cos theta sin theta, 0 to pi, 4 d theta, 0 to 2 pi, 2 sin theta cos theta d theta. integrate 4 theta 0 to 2 pi 2 sin theta cos theta can be sin square theta plus cos square theta is 1, 4 sin theta cos theta, it will take out common, what you'll get 4 minus 4 cos theta, 4 take out common, here 2 can be written as 2 sin theta cos theta, then what you'll get 2 sin theta cos theta is sin 2 theta, then integrate with respect sin theta 2 sin theta cos theta d theta sin 2 theta 4 theta 0 to 2 pi minus 0 to 2 pi sin 2 theta d theta. Sin 2 theta is integration of sin theta is minus cos theta, but 2 theta is there. 2 theta is there minus cos 2 theta by 2, 0 to 2 pi. Apply the limits 4 to 0 to 2 pi, 4 0. Then anyway 0 is 0. Then here 8 pi cos 4 pi. Cos 4 pi is 0 to 2 pi. So cos 2 theta, so cos 4 pi minus 4 0 minus of minus 2 minus plus cos 4 pi, that equal to 8 pi. Same problem is there. Why find the work done by f bar equal to 2x minus y minus z into I plus x plus y minus z into j plus 3x minus 2y minus 5z into k along a curve C in the xy plane given by x square plus y square equal to 9, z equal to 0. Answer is for that 18 pi, x square plus y square z equal, answer is 8 pi.